Hi there, this is Dr. John, your physics and math professor, coming to you with another quadratics quiz or test question for you. This is a word problem, typical to the kind you might have on a test. When Alex rides his dirt bike off a ramp, his path is modeled by this equation, h of d. I've also written this up here using capital letters just to stand out. H of d is equal to minus 3.9 d squared plus 13.1 d plus 8.6, where d is the horizontal distance from the ramp and h is the height, both in meters. How far from the ramp does he land? We've given you a couple of answers, as might be typical on a test, to see, make it a little bit easier for you, a little bit quicker for you. So how do you do this problem? First of all, it would often be good to just sketch a little bit. So this is the distance that he is from the ramp, and this is the height that he is at different distances. So this is sort of like a photograph, time-lapse photograph, where he would be at different heights here, at different distances. So that's sort of easy for us to understand. This equation models this. Now notice here, this would be a parabola that opens downward, as it should here. And it has an x squared element or a d squared element and an x element. I'm going to write that all up here just so I have it right handy for us. So here's the same equation. I just wrote it up here. What we want to know is when he hits the ground. What's this distance here? Well, just like any typical parabola, this could go back this way. Of course, we're not interested in this answer, which is this is the 0, 0 point. This is the 0 distance and the 0 height. We're not interested in where he lands before this point, only after this point. So we're only interested in positive d. So probably there's going to be two solutions to this, one over here, one over here. We're only interested in this one. How do we do this? Well, just like any of these problems, you would say, well, when h is equal to 0, which is this thing, we want to know what d is. So we would just take this and solve for when h is equal to 0. I can erase this. I don't need this sketch right now. And see if we can solve this for d. So we would just take this whole thing, set it equal to 0. Let's just do that. Minus 3.9 d squared plus 13.1 d plus 8.7 is equal to 0. Now we have something that looks like your standard quadratic equation with ax squared plus bx plus c is equal to 0. Let's find those terms. The first term is going to be, the a term is minus 3.9. The b term is going to be equal to 13.1. The c term is equal to 8.7. Since this is probably quite difficult to factor, let's write out the quadratic formula. So d in this case is equal to negative b. Negative b would be this. Well, let's just write the whole thing out. Negative b plus or minus the square root of b squared minus 4ac all over 2a. What we usually do is we start with this thing inside the bracket. It's called a determinant. It will determine whether you have 0 roots. If this is negative inside there, you can't take the square root, so there's no solution to this. In other words, it won't touch the axis. In this case, you know it will. If this has a positive number inside there, then you're going to have 2 roots. If this is a 0, you're only going to have 1 root. So we know this is going to be a positive number, but let's just figure out what it is. B squared is this, 13.1 all squared minus 4 times a minus 3.9, and c is 8.7. And notice there's 2 minus signs here, so that can make that a plus sign and get rid of that minus sign. We don't need it. So all of this is inside the square root. You could just plug this into your calculator. I would do this first and then this and see what number I get. Here I've done the math for you. I've taken everything here. That's all inside the square root. 307.33. Notice we have 2 significant figures basically everywhere here. I've kept a lot more. We'll drop them later. And then I take the square root of that, 17.53. So I'm going to erase some of these things here so I have room to operate right up here. So I've erased this here. Now we're just going to write these things in here. We're going to start off with negative b, which is negative 13.1. Big decimal in there. Plus or minus this number, 17.53 all over 2a. 2 times this. 2 times negative 3.9. All right, we don't need these numbers anymore. We don't need any of this. We're just going to have to continue to do this calculation. So now, before we do this calculation, let's just take a look at this. Notice this is a negative number here, plus or minus this. So if we use the plus sign here, this would be like 4 on the top. But this is a negative number, so we're going to end up with a negative number there. So the plus sign doesn't make any sense. We'll have to erase that. What happens if we do the negative sign? This and this are both negative numbers. We're going to be dividing by a negative number, so we're going to end up with a positive number. So that should work. So let's do the math on this. I'm ending up with 3.93. Remember, we take this on the top first. You get a negative number, divide by a negative number, and then divide by this. You should get this answer here. So this is the number of meters. Is that a reasonable amount of meters to make a jump on? Maybe for a child, maybe not for an adult, but that's a reasonable number for a young person on a dirt bike. So let's just see if that's one of the answers here. So down here we have this for 2 decimals, which is the way that we'd like to have it, since we have 2 decimals for each of these. Well, we have 3 for this one, but we have 2 for these two. So we have 3.9, that's one of our answers. So we check it off, and we're done that one. Of course, if we did the other one, we'd have the negative answer. Remember, I showed you that. Here's where he jumps. He jumps this way. This is the distance that you're calculating with this. And then the negative answer would give you this theoretical answer of what if this was a complete parabola. But in mathematics, when you apply mathematics to physical situations, be that physics or biology or anything like that, then what you have to do is say, what are the constraints within which my mathematics applies? I can't extend it to things and get answers that are not real, that aren't physical. I hope that helped. If it did, like and subscribe. See you in the next video. Bye-bye.